All right, all right, all right. Welcome back, y'all. Welcome back. Let's put away any other work that we've been working on and lend me your ears because today we're going to be continuing our lecture from last Wednesday. Obviously, you're here because you're interested in SwiftUI, and I've somehow convinced you to come back. So before we get into it, if the instructors have any announcements to give.
Nope. Midpoints are due on Sunday, 11:59 p.m.
Midpoint hack challenge submissions are due Sunday at midnight.
If you guys have questions about who your iOS mentors, you can just ask me. Like, I can just tell you who it is. It's already assigned. I think we're just waiting on a couple people to be assigned on design. That's why we haven't announced it yet. But if you have questions, I can just tell you.
Cool. All right, let's get started. So today we're gonna just start with a recap of what we learned last week, and then move on into just talking about a few of the key differences between how you're gonna be implementing in UIKit and SwiftUI. This is gonna be important later for when we talk about how we separate state from view using the SwiftUI model, and then we're gonna talk about how to manage that state, how to share that state, and also think about networking in the state approach. And then at the end, we're going to do another demo following our kind of like lyricist genius copy from last week as well. So starting with the recap, if you guys remember any of this stuff, so we first talked about the different kinds of views that we have. They're very simple. So like instead of a text view or a text label, you just have text. You can put any text. It can be however many lines you want. You can change the foreground color. You can change the font, shadow, frame padding, all those modifiers. There's also buttons, which have a parameter for an action that happens when you click on it, and also a label for what it looks like on the screen. There's an image, which you can kind of enter a string for the name of the image that you want to show up in your assets folder, or you can use a system image. There's rectangles, spacers, all that jazz. And of course, we have modifiers. These are just view-specific functions that kind of change what they look like by a little bit. One important one to remember is frame, which helps you set the size, like the height and the width of whatever view that you're modifying. And then there's also view wrappers, which help you compose multiple views together. So if you remember, a V stack is composing views in a vertical manner. An H stack is a horizontal stack. And a Z stack is in the Z axis, so like coming out of the screen. And then we also have the for each loop kind of thing, which allows you to iterate over a data structure and create multiple views in a programmatic way. And then also a scroll view that lets you scroll up and down. There's also custom view structs. Last time we made our own view struct called saved song row, and then we used that over and over again in a for each loop, if you remember. So SwiftUI makes it easy for that. And then also you can navigate pretty easily using first wrapping your main view in a navigation view, and then enabling clicking something to navigate to a different view using a navigation link. So any questions on this quick little refresher? Cool. So let's talk about some more key differences between UIKit and SwiftUI. Last week, we discussed kind of why SwiftUI is, in a lot of ways, better for faster development of apps, right? Those were kind of reasons to motivate you to keep listening to the SwiftUI lectures. But today, we're going to talk about specific differences in the way that you write the code and the way that you think about what code actually represents. Right, so on the left column, we have UIKit, and on the right column, we have SwiftUI, and each row is kind of a property of both. So the programming paradigm for UIKit is an imperative paradigm. If you're not familiar with what this means, it's essentially every line of code specifies instructions, right? Every line of code is a command, so you can execute it, one line at a time. You can even kind of interpret it line by line. And these are kind of commands for the program to change the state, right? Each line changes the state and runs in a sequential manner. SwiftUI is, on the other hand, declarative in its paradigm. And what this means is that each line of code is more like a general description, right? You declare what the view should look like. It's kind of more so close to a drawing of the UI in code rather than specific instructions on how to build the UI. And I'll give you examples of certain differences in a moment. But one key difference is that you don't really specify control flow, right? Control flow being like, if-else statements, switch statements. You don't really have a strong life cycle that you follow, which is basically saying like every time you see a view, it's just a view, right? It's not like it's a view in the initial state, or it's not like about to get deleted or anything like that. So what you see is what you get, basically. And so for UIKit, the UI components are literally a part of the state, right? There's no separation between the view and the state. So an example of this would be when you create a label, right? You bind the label to a certain variable, let's call it like label. And then if you want to change the label's font, you say label.font equals some font that you want. And then if you want to change the size, you say like label.font.size equals something. And so that requires multiple lines of code, and also you're line by line changing, you're referencing the label as like a certain variable, and then you're changing the state with each line, right? The state is being like the font and the font size. But in SwiftUI, you create all of these modifiers all in like one kind of reference, and you don't have to bind it to a variable if you don't want to. And then the view is kind of static, right? And the only way the view changes in UI updates is whenever the state changes and it reacts to those changes, right? A lot of these words kind of don't make sense right now, but I'll make sure to give you examples later to really show you how this works. And then the last thing is kind of what we're covering today is data flow. So in UIKit, data flow is handled using your view hierarchy, right? Your delegation/protocol systems, which you've learned in previous lectures. Global notifications, which is another really good UIKit tool, but can end up being messy if your code base is too big and there's too many notifications going around. And then in SwiftUI, it's very, very simple. You just pass variables between views, right? The data flow is handled when you have a parent view and you just initialize a child view with whatever data you want the child to inherit from the parent. So I'll give you another example for that later as well. Any questions about this so far?
Are you supposed to be on mute?
Yeah,
Okay.
yeah. My computer's recording the audio. This is just like my Zoom thumbnail.
Okay.
Yeah. Cool. So next we're going to talk about separation between the state and the view, right? This is where we depart from UIKit. This is a pretty crucial distinction because it allows us to kind of say, there are a certain number of states that are possible with a particular UI, and we don't really want to consider any other state, right? So like when you have a button on the screen, it can either be on or off, right? Or it can either be like unclicked or clicked, right? Separating the state out and like making sure that you can cover all of those potential states is what allows SwiftUI to be so much simpler, right? Because you don't have to have like particular selectors/items for whether a button is clicked or not. I don't know if that makes sense yet, but I'll show you. Okay, I will do. You'll probably learn more from this lecture by me showing you things than explaining things in words, but I do want to get the fundamentals out there. So we take a declarative approach to building a UI. That specifically means that we separate the view and the state and declare what the view looks like for any state, any given state, right? And there's only like so many given states, which is great. So the view corresponds to strictly UI components, and it may depend on data from the state, but it's deterministic, right? What this means is you can kind of envision a view as like a function. The inputs are the state, and the output is what the view actually looks like on your user's screen. And so as long as you have the same inputs, you always get the same outputs, right? That's what deterministic means. And so since the inputs are kind of state, and the inputs are limited to a certain set of the variables, you can have very expected behavior for your UI, right? You can really factor out a lot of bugs that end up happening if you, for example, in like UIKit, if you miss a single line, right, your button may look super out of whack. And this helps us avoid that. So state is also stored, and you can choose to share it between views. You probably want to share it between views if you want to handle like navigation logic and stuff like that. And changes to state will automatically trigger the UI to refresh because the inputs have now changed, right? So then the outputs will change. So it'll trigger the UI to refresh, and then it will reflect the new state. So like I said, you can think of the UI as a function of inputs and outputs. So the function, you can think of it as like a function called makeView. And this is like the views, right? This is what you actually write in your var body in a SwiftUI file. And then the inputs are the state, and then the output is the actual UI that you see. Cool. So next we're going to talk about managing state, right? How do we modify the state and also react to the changes that we'd made? So let's say you have a state variable called button press count, and you want a piece of text on the screen to change when you've pressed the button 5 times, right? Any other number of button presses just tells you to keep pressing, right? In this case, the logic's not perfect. You know, if you press it 6 times, it's going to say keep pressing and really troll you. But once you get to 5, it's going to say congratulations, you've done it. It's not a typo. And these are different ways that you can do it, right? You can have an if statement and check whether the button press count is 5. You can have a switch statement, which also, you know, checks if the value of button press count is 5, and then by default, if it's anything other than 5, it'll say text keep pressing. And then this is the ideal way to do it because you can do it in one line. Here I use a ternary operator. Is anybody not familiar with ternary operators? Okay, ternary means like 3. This just means it takes 3 inputs, right? So the notation here is you have a question mark, which sets up the ternary operator. So it takes in a Boolean on the left side, which here it's checking if button press count is 5. And then it has 2 cases, right? If this is true, then it evaluates the first statement. And then if it's false, it evaluates the second statement. And so you have the colon to separate the true case and the false case. Does that make sense? And so this is like a single line solution to that. And like this entire thing evaluates down to one of these strings, which becomes an input for the text component. Does that make sense? Cool. So this is how you react to the changes. And now I'm going to talk about, or I'm going to give you an example, right? I'm going to play this demo real quick. So when I tap the toggle, it changes the emoji, right? So this is 2 separate components. We have a text, which is just a really big singular emoji. And then we have a toggle button, or a toggle. And so if you look at the code, we have this toggle is bound to this state variable here, right? We declared the state variable at the top, which is kind of the default. And notice that I mark it as state, right? I can have other variables that are not marked as state, and they will just be considered as constants, right? Because state is the only thing that really tracks the changes. And also notice that I use this $sign notation in front of the state variable. This just means that I create a 2-way pathway between the toggle and the actual value of this variable, right? So when I tap this toggle, the toggle will actually change the value of isDay. And then if I also change the value of isDay from somewhere else, this toggle will automatically change back to the other value, right? So it goes both ways. And so this essentially is like a binding, okay? I will talk more about bindings in a second, but state variables allow you to do that in SwiftUI. And then here in the text for the input, I use another ternary operator like I did on the previous slide. And this time the Boolean that I'm operating over is isDay. And so when it's daytime, we want the sun emoji, and when it's nighttime, we want the moon emoji, right? And then all the other modifiers are kind of just like UI stuff, right? Does this kind of make sense so far? Cool. So now let's talk about modifying state. You can really only modify state in SwiftUI during particular event blocks of code, right? So this an example of this would be like in event parameters, right? These are pieces of code executed when a user interacts with a UI component. So last week when we had a button, the first parameter was a completion. You entered in a block of code, and this is where you can execute lines of code like print statements, right? These are imperative lines of code that always modify the state, but don't really affect like the overall state unless you choose to, right? So this is a good place for you to modify the value of a certain thing, right? In our button count example from before, if I tap the button once in the action completion or in the action code block, this is where I would say like button press count plus equals 1, right? And then there's also event modifiers, and these are modifiers that you add to the end of a component. So like dot on appear, dot on disappear, dot on tap gesture, and dot on change of like some variable that you're observing. And these are kind of more so optionally implemented parts of the lifecycle. So when your view shows up, it'll automatically call on appear, right? If your view, when your view like disappears, it'll call on disappear. But this is only when you like implement those modifiers, right? If you leave those out, it won't trigger them at all, and nothing will happen. And one thing I want to note is that if you have state modification lines of code outside of these event blocks of code, your program won't behave as expected because you're actually moving the state modifiers into the view code. Does that make sense? Your view code is executed over and over every time a state variable changes. And so you don't want to change the state variable and react to it with another change, right? That's like answering a question with a question. You don't want to do that. It doesn't get anywhere. So here's another example that kind of helps you visualize the button press count thing. So play this thing right here, and then this will navigate to a page saying congratulations or congration, you done it, right? And so let's break this down line by line. At the top, we have two state variables. One is the button press count, and the other variable is show reward, right? The button press count tracks the number of times you press the button, and then show reward is kind of a trigger for the navigation link, which is down here. So this is a constant. Okay, button press goal is a constant that just like always gets reset to 5, even if you change it in some of your event code. This is because SwiftUI views are structs, right? Whenever you modify a struct, it creates a duplicate of it with those changes, and then anything that is not like stored as a persistent change will just be reset to the default value. And in this case, this variable that's not wrapped in a state modifier or in a state property wrapper will just be reset to 5, right? Or reset to what it's initially declared as. Cool. So we have a navigation view here. That's how the navigation logic is enabled. And then this is just instructions to press the button 5 times. This score tracks the button press count, right? So every time this variable changes, we will reload this text and change the input to whatever the new value of button press count is. And then this button right here is where we actually have the event of changing button press count, right? This is the action parameter that we saw here, right? That's the first parameter that we entered into the button initializer. So that's actually a block of code, and it executes every time we tap the button. And so by default, it'll always increment by 1. But in the case that the new button press count is 5, we will print this just for logging and debugging purposes. And then we will also set show reward to true, right? Show reward, when it gets set to true, changes, or I guess refreshes the navigation link. And we have bound show reward to the isActive parameter for the navigation link, right? When the navigation link is active, what happens? We show the next page, which is just a piece of text that says congratulations. And then otherwise it's empty, right? Last time we covered invisible navigation links by adding an empty view to the label, right? So this is just kind of like in the background, but it's still observing the state. And then notice how I don't have any state variable modification lines of code outside of the lines of code that are strictly like event related, right? So I'm gonna have an exercise for you later to identify which parts of the code are like imperative event code and which parts of the code are view code. But we'll get to that eventually. Oh, yeah, we'll get to that now, actually. So I'm going to play this demo again, or this other demo. Right. Well, basically what's happening is I have a button on the screen, and every time I tap this button, it's changing the selected tab variable to the other state, or I guess it's changing it between like 1 and 2. So let's see. How do I want to do this exercise? Somebody want to come up and just like point your finger at which parts of the code are view and state code? You, come up. Yes. What's your name?
Neha.
Neha? Okay. Thanks for volunteering, Neha. Yeah, okay. Take a shot.
I was thinking this, like here,
Mm-hmm.
would be the imperative code,
Yeah.
and then this here is like the view code because you're changing it in the view.
Mm-hmm.
This also
Yeah?
imperative because it has the operator, and then this up here
Yeah.
is off.
So I do want to have or add a comment. So you did identify this correctly. This is the only place in the code where you actually have an action that's triggered, right? Basically, this just changes the value of the variable. The other two places where you identified, or I guess several places where you identified it to be also imperative code, is actually more so just like reactive code, right? This is where we're reacting to the changes. So here we change the value of selected tab. And then, let's see, selected tab here is actually where we react to the changes to selected tab, right? This tab view behaves in a way where whatever value this is, it will select the element, or it will select the page that has been tagged, right? So this function right here produces, given a certain tag, one of these pages, right? If we break it down, we have a background which reacts to the tag. If it's 1, then it'll have like a pink background, and then if it's not 1, then it'll be blue, right? And so this is where we kind of like react to the changes to the UI code, and this is the only place where we modify the code. And then all the other pieces of code are like specifically view code, right? So I guess I omitted the part where you have to like specifically have parts of the code that are reactive rather than like imperative or view related. Does that make sense?
Yes, that does.
Okay, cool. Thank you. Yeah. Sorry I just like called you out of the blue. I didn't want to waste any more time. Cool. So this is also another example of a way that you can use functions to create a view, right? So this is kind of a state variable, or I guess it's a certain input that gives data on how the view should look like, right? And so this data is related to the tag. If it's tag number 1, right, like tab number 1, then it'll look like, red. It'll say like change to the button will say change to the other tab, and then the tab item, which is the icon at the bottom, if you can see that right here, the image is different depending on what the tag value is, right? But yeah, very good. So I have highlighted here all of the like state-related code. And I say state-related and not necessarily imperative, right? Because they kind of go hand in hand. You have what modifies the value of the state and what reacts to the value of the state. Everything else is view code. Cool. So next thing that you're probably interested in is sharing state And sharing state, the goal of it is to synchronize data across the views, right? And so let's use another UIKit example, right? You want your detail view controller to be able to change the value of something on your home view controller. How do you do that? You write a protocol, you have a certain like modify function or like pass information back to home function that you force your delegate to implement. And in this case, your delegate is like your home view controller, and then your detail view controller has a reference to the delegate, right? And then when you're done, you say delegate dot complete or delegate dot modify into whatever the new value is, right? Here, what we do instead is just say we just have a special kind of variable that if you modify it from anywhere, the changes will be reflected everywhere, right? And that brings the question of who has access to that, and we'll talk about that in a second. So state has two behaviors or two possibilities. You can reactively update the view, and you can also keep the data synchronized between the view, right? So you can react to the changes made on one screen from another screen, basically. And so here we want to distinguish two types of variables, owned and unowned, right? So an owned variable just means that the view that created the variable is the owner of the variable, right? Owner views can share their variables with child views, but they hold the source of truth, right? So every change kind of gets propagated back to this owner view, and then only one view can own this type of variable at a time. But you can allow multiple views to access it. And then unowned variables are just the access version of an owned variable. You as the child of a parent view are given access to a view or a variable that they own. And so when you update this variable, it just passes the changes up to the parent, or I guess whoever owns the variable. Any questions on this so far? I think this is a pretty intuitive abstraction of how the types of variables work. So let's look at this demo again. So whenever I tap the emoji, it shows another screen that keeps in sync the value of whether it's daytime or not, right? Let me play that one more time. So whenever it's daytime on the first screen, it's also going to be daytime on the other screen. And whenever it's nighttime, it's going to be nighttime on both screens. And you can change the value of whether it's day or night from either screen. And that's how we know that it's synchronized, right? Let's pay attention to that when we watch this again. All right, so it's nighttime, it's daytime. I can change it back to nighttime, and it's nighttime. Cool. So let's break down how I made that happen. On the left side, we have, or I guess I can start with the right side. Let's start on the right side. This is the parent view, right? This is content view. And so this is where we have the sun and moon emojis. And then we have a navigation linking to the child view, right? And notice that in the child view, we pass this particular binding variable, right? Or we bind this state variable to the child view's binding variable. And I'll talk about the differences in a second, but essentially this allows me to change the value of isDay from the day-night view screen and have those changes be reflected on the content view. Does that make sense? Everything else is just view code, once again. So as you've noticed, there's like a bit of at notation here, right? We have at state and we also have at binding. And these are examples of property wrappers. Okay, property wrappers are essentially modifiers of certain variables that make them behave in a certain way in relation to how state changes are made and who owns and who doesn't own certain variables. So state is one of them. It's probably the most common one and easiest to understand. But there's other types of property wrappers. And this is the table. You don't have to know all of these. I would recommend just being familiar with state and binding. So let's break it down. So state is just a simple piece of value type data that's localized to a single view. Value type means like an int, or just like a very primitive data type, right? If you modify it, it just creates a copy of it, a new, better copy of it, right? And a binding variable is basically the child of a state variable. So this is also value type data. But when you have a binding variable in one view, you know that it's owned by another view, right? Whatever value it is has been initialized in another view. And so when you change this value, you know that this change is being sent somewhere else as well. And then state object is the same as a state variable, but it stores reference type data. And so you can create your own custom state objects by conforming a certain class to the observable object protocol. You can look more into that if you want, but this is kind of going beyond our purposes for today. And then the observed object is kind of how binding is for state. It's just an unowned version of a state object. Does that make sense? And then a published variable is a kind of variable that you would want to include in a state object when you're implementing it to basically say, when this variable's value changes, I want to broadcast to the entire view and trigger a refresh, right? So like not all the variables that you need in a particular piece of data are subject to change, or when they're changed, like you want to refresh the view. So this is where you specify which ones actually want to trigger a UI refresh. And then an environment object is SwiftUI's way of creating global variables. And so like if you want to have a certain user setting propagated down, like let's say the user wants their screens to be in dark mode, right? This is what you would put in an environment object and have all the subsequent views from your content view access that the screen should be in dark mode at that point. So that's one way to have global variables. Cool. So actually, does anybody have any questions on these? All right. Cool. So last thing is networking. And in networking, it's slightly different than the traditional state that I just showed you. That state, those changes happen instantly, right? But networking, you have kind of an intermediate state when the request is going to the server and coming back, and your app has to wait a little bit, right? That's kind of the loading state. And yes, loading is a state that you can capitalize on to make your UI actually look more reactive, and you can kind of indicate to the user that like you should wait. And so our goal is to clearly communicate to the user that like something is processing in the background and they should be waiting, and just like don't be impatient, right? And so this is where you would have something like a loading indicator, you know, a spinning wheel when your YouTube video is buffering, or a shimmering view, like something that changes from dark to light to show that like maybe an image is loading. And so in SwiftUI, we can easily use enums to represent the loading and loaded states, or in our case, on AppDev, we use results as the name for that. And so we show different views depending on the state, right? We react to the enum that holds what the state is currently for the network request. So here's an example. I'm going to play this demo again. So what I've done in this piece of code is down here I have a fake network request. And so I request an image, and then after 3 seconds, I call the completion, right? This should be in the same pattern as you're familiar with from the other networking lectures, where you pass in a certain piece of code to execute once the request returns. And so this request just returns after 3 seconds. And so in those 3 seconds, we are checking whether or not our state is either loading or with results and has results ready, right? I just bind the data into the results. And so whenever they're ready, I can pass them to wherever I need to like send them. And so here, once again, this is the onAppear modifier that I mentioned at the beginning of the lecture. And I have some imperative code that's run. And so here I call the fetch image function. It waits 3 seconds and then executes whatever's inside here. With animation, just makes it look more smooth when we actually do receive the results. And then all of this is stored in a state variable called request state. And by default, I set it to loading because I know that when this screen appears, nothing is loaded, right? So I just assume that it's going to be in the loading state to start off with. And then when it's done, I set it back to the results state. And the screen automatically changes because I bound it to a state variable, so we're observing for any changes. Yeah, Noah.
Why do you create a new enum instead of just using an option?
Because there's not a good and elegant way to switch case over optionals.
If-let.
Yeah, if-let doesn't have like very. I guess you could do that. I just chose to do this. And I think optional handling is less clear on like what the specific states are. Right? The whole purpose of having state separated from views is that you limit the state to a certain small, like the smallest set of possibilities as possible. And optionals just like is not clear enough. You know what I mean? There could be multiple reasons for why a certain piece of data is optional. Whereas you know that if a state is loading, that it is loading, and if you have results, then you have results. Does that make sense? Okay, I'll show you a case later. But yeah, I guess if you want to use optionals, you can. But this is just kind of like following the philosophy of having very clearly delineated states that are possible and factoring out any unexpected behavior. So in our view, we react to the value of request state in this switch case, right? So we switch over the value of request state, and we have either the loading case or the results case. So in the loading case, I have a skeleton view, which I'll show you in a different file. But this is basically like the square that was, pulsing, right? We call it a skeleton view because it doesn't actually have any information, but at least it covers the same area as the final image should cover, right? So we're not creating any like layout changes. And then once we get the results, we have the results bound to the enum with an associated value, and we wrap it in a variable called image name, and then we just show the image. So does everything make sense in this setup? Cool. So in apps in Volume, which is the only app on AppDev that's written in SwiftUI, we use this structure to basically cover all of the images and articles that are loading when you first open the app, and it looks pretty cool. All right, so before we get into the demo, does anybody have any questions that I did not get to answer? Yeah. Yeah, I was going to get into that. Cool, so let's get on with the demo. Do you actually have a question?
I had a question. On the previous slide, is the 3 seconds like arbitrary, or how do you determine that?
Oh, the 3 seconds is arbitrary. I just wanted to show that there's like a significant amount of time between actually making the request and receiving the response. Yeah. All right. So now we're going to watch me write some code. Cool. So everybody has the Git repository still, right? From last week's demo. I created a new branch called L2 starter. And so that's going to be the starter code for today's demo. So how you get there is I'm assuming you have the repository cloned already. So first you would do git pull, and that'll bring in all the changes. And then I would do git checkout L2-starter. And here I'm already on starter, but you would use the same commands to get there. Let me know if you have any trouble getting there. Thumbs up if you're ready. Oh, it's be real time. I think I'm too late.
You're gonna be in the recording mode.
That's okay. All right. Okay, we have 7 minutes for this demo, so I'm just gonna go ahead. You can check the complete code by going to the L2 complete branch as well if you lose your way. So I'm going to open up Xcode and start to type. All right. Give me 1 second to pull up my reference. Resist. Okay, so let's see. Branch complete. All right, so the first thing that we're gonna do is figure out, what changes are we gonna make to the code. Let's see, or what changes we're gonna aim for, right? What are we gonna implement? So from last lecture, we just had these screens. This time we are, oh, god damn it. This time we're gonna add a favoriting feature. And this really uses state because we want to make sure that if one song is favorited, that when we open up the lyrics for it, we can also see that it's favorited. And then I also added another change that's not in this Figma file. Maybe we'll get to it, maybe we won't. But there's going to be another heart here that allows us to hide all the songs that we haven't favorited. Cool? All right, so let's see. We got the starter code. Let's check out what we got so far. So this is kind of just pretty much the same as L1 complete, the end of last lecture. But the first thing that we want to do is actually make song into a, we want to add the property of whether a song is favorited or not, right? So I'm going to add that here. I'm setting it to be a variable here instead of into a var variable instead of a let variable because we want to be able to change it, right? And then because we are, if you remember in saved songs view, we're iterating through it in a for each loop. We want to make it conform to hashable by implementing the hash function. So this is just this is part of the hashing or the hashable type protocol. We have to implement hash. So how you do it is hasher.combine and then any of these values, right? I would do all the values because I want to make sure that if one song's album name is different from another's album name, that I hash them into different buckets, or I just basically consider them to be different values. So this is going to be a little tedious, but I'm just going to get through it.
I don't think you actually need to do that.
Trust me, we need to do it.
It has a default for structs.
I will show you later why we have to do this. Notice how I didn't include isFavorite in here. I didn't include isFavorite into the hasher, right? When we change this value, the associated binding to our song lyrics view is going to make this value into a new one and erase the reference to it. And it's just going to break the system. So this is not arbitrary. If you have questions about this, I can answer them in depth after lecture if you want to stay over. But yeah, so that's the first step, is to make sure that our data model has the property of being able to be favorited, right? The next thing is let's modify our saved songs row so that we see whether a song is favorited. And so we know that we're gonna get the data for this song from our saved songs view, right? This is our child and this is our parent. So when we change this, we wanna say at binding instead of state. Okay, so now we know that this song, every time we change something here, it's gonna be reflected on the home screen. And then I guess here, I've already populated it with a heart. Or it'd be helpful if I kind of just ran the yeah. Oh, I forgot to do isFavorite by default is false. Just kidding. Okay, let's not make it a binding variable yet. But yeah, we'll boot up the simulator real quick. And then we see that we have a bunch of hearts. We should see over here that we have a bunch of hearts that are not filled in. This means that by default, everything is not a favorited song. If I click on it, it'll just show the lyrics view because this button is not active yet, right? Or I guess it's just an image right now. So we're gonna actually wrap it in a button. And so the action is going to be song.isFavorite.toggle. So it's going to toggle the value of the of whether it's favorited just by tapping on the actual heart. But let's run it again and see if it does anything. Well, actually, it doesn't allow us to do anything because it's saying that self is immutable, right? That's because we're in a struct. So you can't actually modify it unless you wrap it in some kind of state variable. So I'm going to mark it as binding. And then when I build it again, it's going to tell me that I need to make sure that this is a binding variable, right? So how do we do that? First of all, we can't modify it from the home screen, right? That's because we have it wrapped in a let variable, and it's also not a state variable. So it's going to be kept as a constant. So let's wrap it in a state variable, call it state var songs. And then on the for each, instead of iterating over the actual value of the songs, we're going to iterate over all the bindings to the songs. Okay, so this enables us to apply the binding or send the binding over to any child views that we have. This creates like the two-way highway that we have. Let's see. So I'm going to do that. And then this is also kind of putting the binding in there. And then in the saved songs row, I think that should be okay. And then here, I think I have to put hash value instead of the actual song. Maybe I just put song. Okay. So this is giving me an error because we haven't added a binding variable to song lyrics view either. So I guess we have to do that first. I'm going to also call this binding var song. Okay. Now the build is successful. So what changes did we make between last run and this run? Well, we made it so that when we click this button, it should be able to favorite it, right? This button works, or this button doesn't show the like lyrics view, but and that just indicates to us that there's a button there. It's doing something, right? But the change is not being reflected because we haven't actually reacted to the change of the variable, right? We just have the same system image here. So how do we react to it? Well, what we do is, once again, a ternary operator, and we're going to use the condition of whether the song is a favorite, right? Song.isFavorite, open the operator. If it's favorited, we want to fill the heart, and then if it's not favorited, we just say heart. Let's run that again. So now when I click on this, it's going to change colors. But when we click into a lyrics view that's not favorited yet, we still don't, see this reflected there because we have neither reacted to the changes nor actually even made it into a button. So we can do those two things now. Is everybody kind of following so far? Am I being a little confusing? All right, cool. So let's go to the lyrics view and react to those changes. Where is our heart? All right, so we're going to do the same thing here. Heart.fill. All right, and then we also want to wrap it in a button. And what does this button do? We also want to toggle the value of the favorite, right? All right. So now all of the expected behavior that we have in the Figma document should appear. Yay, right? This song has been favorited from the home screen, and it also shows up as a favorite on the lyrics screen. If I tap this and unfavorite it here, it will also unfavorite it here. And so that's because we have created a two-way, or I guess three-way in this case, because we have two different child views. We have our save songs view that owns the variable of the song and the value of whether it's a favorite. And then it passes that same value to both of these views, right? It passes it to the row, and it also passes it to the lyrics. Cool. So everybody following so far? I do want to get to the filtering because that's also like another example of state management. So let's go ahead and make the top button or the top heart icon into a button as well. So we have save songs view. We want to react to whether we have selected favorites yet, right? So we're going to make that into another state variable called show favorites. It's going to be a Boolean, and by default, it's going to be false. And so whenever, let's see. First, let's talk about where we want to modify this value. We want to modify it from the heart button, right? So I'm going to wrap this in another button. Do the same thing. So show favorites dot toggle, and then once again, let's see, fix the indentation on that. So this is where we modify that value, and then where we react to it is, first of all, there's going to be two places. First of all is what the heart actually looks like. So show favorites question mark heart dot fill, and just our regular heart. And then also we want to just not show any rows that have not been favorited, right? So this is very simple. We say if song.isFavorite, we show it, and then otherwise it does nothing, right? We don't have an else case. It just returns nothing. Oh. Okay, yeah. So this error here, every time you get an error of like cannot convert value of binding of a certain type to the actual type, you just unwrap the value. Once again, these are property wrappers, so it kind of adds like another layer to it. And then if it tells you that like the layer is not the actual value, then you just unwrap the wrapper. So we say song.wrapped value.isFavorite. And another cool thing is that you can unwrap it at any point. So you can even unwrap it like afterwards, and that'll work too. Oh, okay, I forgot a thing. So I only want to not show the favorites if I'm like, if I have the favorites filter on. So let's see, if show favorites, or it's not favorited. I think that's the Boolean condition. Oh, that's not right. I wish we had a Boolean algebra class here. I definitely would have failed. If not show favorites. Okay, that's the one. Yes. Okay, so I will favorite these, and when I click this, only they will show. And it can also work just like any parts of the row, and it'll maintain the order. I go in here, unfavorite it, won't be favorited anymore, filter again. There we go. That's it. That's the demo. Cool. So if you want to check out this code later on, there's already a branch with all of it there called L2-complete. So go check it out, and hopefully you learned enough SwiftUI from these two lectures to feel confident enough to do your hack challenge project using it. If not, you can always ask me questions, office hours, or just email me. I know I have like my assigned mentor groups, but you're welcome not to talk to your own mentor and come talk to me. So yeah, thank you guys.